For this example, we're going to sketch the graph of this function. And we're not going to do the steps we had done in the previous examples with this function, because since this is the cosine function, remember the periodicity identity. The periodicity identity said that cosine of t plus minus 2 pi is equal to the cosine of t. When I have the cosine of negative x plus minus 2 pi, this is the same thing as the cosine of negative x. Okay, and what that means is that no matter what this is here, if I go around one turn, I'm going to end up at the same place. If I go around the other way one turn, 2 pi, I will end up at the same place. Here, I'm going to sketch a little. Here's where this would be your angle negative x, or negative t if we're going to use t. Okay, here's negative x, and this is saying negative x plus minus 2 pi. So if I'm here and I go around 2 pi, that means a full 360 degrees. That means from negative t, or from negative x, all the way back. That's a full 360 degree turn. I end up at the same place I started. And if I go around the other way, if I go around, if I go around this way, from here all the way around 360, I end up where I started. So plus or minus 2 pi doesn't matter here. That means that going around either way will get me back to that angle of negative x. So this is equal to cosine of negative x. And another identity we have with the negative angle identities, we had said that the cosine of negative x is equal to the cosine of x. And let me sketch that for you. If this is angle x, this angle, when it hits the unit circle, will have an x and a y coordinate, right? And we said the x coordinate is cosine, and the y coordinate is sine of x. Okay? So when we have negative x, the cosine for both these points are positive. They're the same ones, the sine of x. The value for this x-coordinate is exactly the same value for this x-coordinate, because quadrant 1 and quadrant 4 will have the x-coordinate to be the same value and positive. Okay? So using the identities, I've saved up a lot of work. So from sketching this big function here, I've reduced this down to just sketching the cosine of x. And that you should be able to do. Let's say this is 1 here, and let's say this is negative 1 here. And we know the cosine starts at 0, 1. We have our 4 key values where we hit the 0, reach our minimum, hit the 0, and reach our maximum. And there is your function, okay? That is cosine of negative x plus 2 pi, and then you can continue sketching this cycle throughout. Whoops, sorry about that. Did I do this right? Let me see. 1, 2, 3, 4. Then you can continue either way, okay? And that's all you need to do for this one. It's that simple. So take advantage of knowing these identities and learning to identify them so that you can use them to your advantage. I want to show you in GeoGebra how this looks. It's very interesting. Notice here I have cosine of x. I'm going to show you the original function, cosine of x. There it is. If I graph cosine of negative x, watch what happens. It's exactly this, wait, there. It's exactly the same function as cosine of x. Okay, there. So there's no graph now. I'm going to show you cosine. There it is. Here's cosine of negative x, and watch, it's the same identical graph. And if I want to show you the graph that the function that was given to me originally, which is negative x plus 2 pi, watch this. It stays on that same graph. Okay? Notice when I'm over the graph, all three functions light up because it's telling me that this graph is functions p, q, and r. Very interesting, right? So we arrived here by using the different identities. I hope this helps you, and I will try and do another video on similar problems like these. Okay?